Okay, everybody. The company's name is ENLYZE. We have Dennis Zahner. He's one of the co-founders, and I hope that if you're not sitting here, you're still paying attention. He's going to be speaking about creating a sustainable supply chain and the importance of the regulations coming. Thank you so much, sir.
Hello, hello. Okay, it's working. Perfect. First of all, thanks for the lovely introduction. That being said, because actually my co-founder was going to give this presentation, we had to do a switch over really quick. So I'll be rather focusing on going to a smart factory from 0 to 100 and what this entails. But nonetheless, everything starts with data, and this is what this presentation is about. So let's first of all define some learning goals. And I have set 3 for this presentation. First of all, it's what does it actually need for digital transformation? And also, second, what are the technical challenges? Because obviously one can go a long way speaking about the cultural ones, but the technical are equally important. The third question is, why does it sometimes start so quickly and then slow down so fast? Each and every one of you have maybe done a project who knows like the prototyping phase is super quick, everything moves so fast, and at some point it really slows down. So I'm trying to shed a light on this based on our experience within this field for the past 6 or 7 years or so. So instead of shining or shilling our product, let's take a journey. So let's imagine that we are actually digital transformation managers at a company. So right now we have been working for like the past 5 years in this big company. They have a huge IT. They have built a data platform that allows you to just tap into any data you want, be it machine data, operational data, and you basically work at the intersection between IT and the different departments. You identify pain points, the problems of the departments, and you come up with innovative solutions. And you basically are the product manager of this thing, and you work closely with the IT to figure out what data you need and how the use case should look like. And after 5 years, it becomes somewhat boring, and you're looking for a new adventure. And be it as it may, a headhunter nails you down, and you have a new employer. So you switch places, and your new employer now is an SME. It's a production company with around 2,000 employees. It's family owned. It has been for the past 50 years or so, and has grown organically. In recent years, though, although you're a German production company maybe, and you're a hidden champion, rising energy prices, lack of skilled workers, and foreign competition has put you increasingly under pressure. But that being said, you have overcome many challenges, and you have identified as a company that digitization is the only way forward. You know there's a lot of manual processes, and you want to kind of innovate. And we, as a digital transformation manager, we are cast into that role, and our job is to kind of get this uplifted and start the journey towards a digital future of the company. So what do? It's our first week. And usually we just sit in and listen because obviously we don't know anything about this company, want to understand what is going on. And many people have a lot to say. For instance, the sales manager or the head of sales tells us, well, actually, we only know that quarter after quarter we are hitting numbers and we are not in the reds, everything is turning a profit, but we can't actually pin down which product is making that profit. We just know that we are profitable. Also, the head of R&D tells you that one of the biggest challenges of her has been to understand how to scale up new product development really fast, and they are having back and forth with production because everything is good at a small scale, but when it comes to really pushing this onto the shop floor, they're having issues, things get out of hand, the process is unstable, you don't know how to manage it. And obviously, the production manager or the operations manager, they have like plenty of issues in mind. Like for instance, they don't understand where controlling gets the numbers. They haven't really produced that way anyone in the past or will in the future. And also, worker shortage has been a problem. It's getting worse, especially considering that within the next 3 or 4 years, 20% of the workforce will retire eventually, and it's really hard to find a good replacement. And when you just ask, okay, so what about data? They say, yes, sure, we have data. If you want, you can go down to the storage unit. We have 100 of folders. just look in there, find the line you're looking for, that's it. Or if you want to be super futuristic, you can also put a flash drive into your machine, not every, but this one over there, and you can get a CSV download from that and look at the data. It just takes 2 hours. And slowly you begin to develop like a good understanding of where they stand, and you have the feeling that especially operations and the production manager is somebody that you can really help in a good way. So you go and down and just chase down a problem. It's called problem selection. And you, first of all, want to create a proof of value to get people excited about what you're doing, because you're a new person, you have a new role, you're costing money, and you have to convince that you have a reason to be there. And you have a sit down with the operations manager and figure out, okay, so in the past 3 months, 5 experienced workers have left the company, and it's really hard to find any replacement. And due to long-term absences, sickness, mental health issues and whatnot, 6 more workers are sick, and this leads to understaffed shifts, and this in turn leads to really high scrap rates, just because the workers really don't notice when a machine is producing scrap, or the running times are super long, and it just runs for hours until somebody stumbles upon the issue. And this is so relevant that even the plant management and the COO knows about. And you think, okay, this is a really good thing, we can really rep this out, and you set out to do a plan, and 6 weeks later you come up with this setup here. This is like a small Raspberry Pi. It's a small computer that you have purchased by yourself. You have just taken a Python script, repurposed it. You have an MQTT broker running on that thing, and Grafana, which is just like a small time series visualization tool. Everything is running on that little computer in the on the shop floor, and you have connected the most modern machines, which are like from 2022 or something. And you have big TV screens in the shop floor and worker alerts that just alarm the workers as soon as the machine is producing scrap. And that's about it. And you wait another few weeks, and obviously the results are remarkable. So just because the workers have the notification, they are able to run to the right machine, do the right steps, and reduce the scrap. This has led to overall 30% of scrap reduction. The workers jump in to help each other as soon as they see on the big screens that something is wrong. And the COO is obviously thrilled. This has been an issue for the past few months. And he says, okay, awesome. We want this everywhere. Like, this is great. We need this not only on these machines, but also in Pulheim, which happens to be a small city next to Cologne. And definitely, we also need to store the data. The last part confuses you, so you just go down and talk to him again, and the COO tells you that second to the scrap problem, the R&D department has been trying to introduce new products to the line, and this has been a strategic thing that has been going on for the past few months. It's going to be really important for the company for the long-term sustainment, and thus they need to store and analyze the data to really understand what is actually going on and why they can't make that shift from the laboratory to the full-on shop floor. You decide, okay, that makes sense. It will just deliver another value stream, so you just plan that in, and you head out. So your plan now is a bit more complex. Well, okay, we did it once, so how hard is it to do it like around 50 times over? You already know from your old employer days that there are basically 3 components. You have connectivity. Before you actually can talk to the machines, let's say, you can't get any data out of it. Then you have to capture, process, store, and make that data available. And third and last, you have the application that actually delivers the value and does something with the data. Because nowadays, actually, from our experience, it's really hard just to sell something that is, hey, here's the data, do something with it. Most of the manufacturing companies don't happen to have data scientists on the payroll. So, since connectivity is basically the hard requirement, we start with this. So we set out, we just go over the shop floors in Cologne and Pulheim. We have an Excel spreadsheet, and we look at all the machines that they are and the PLCs, which are like the small controllers that actually automate everything on the machine, and figure out, okay, so what PLC is it? Does it have OPC UA, which is a industry standard protocol, or is supposed to be, where you can basically easily connect, it's open, it's documented, and it's fairly easy to implement. And turns out, unfortunately, the only 3 machines that boast OPC UA are the pilot machines that you have selected. Most of the other machines are way older, they have arcane protocols, you don't even know how to pronounce some of their names, like what is backoff, and you stumble upon the first learning that we have made within the past 6 years, which is that connectivity somewhat is still not really fully solved. Like most of the shop floors have grown organically and boast many different protocols. Our personal record has been like 20 some on just, I think, 6 or 7 machines to connect all machines in the periphery. And also sometimes not all relevant data is also captured on a central PLC. So you have to go down to the peripherals, understand their protocols. They sometimes also cook their own soup. It's really hard to just connect everything, especially if you aren't in a greenfield setting. And how do people solve it today? It's basically either using OPC servers such as Kepware, Ignition, or others that you basically pay on an instance basis, or you go to expensive OEM upgrades that basically you pay the OEM and then you get an OPC UA server, but this is really costly for them as well because most of them also aren't that digitized, so it takes them a lot of manual labor to come up with a tag list and whatnot, and many also don't offer it because of that. Well, when life gives us lemons, what do? Well, actually, 4 months later, we have made lemonade. We have set up machine networks with switches. We have 32 Windows IPCs set up, 20 times Kepware, 12 times Ignition, and also we have all the data sources set up. And this is what we have done so far. We know that's a lot, but well, it's infrastructure. We have to do it. We'll just move on. So what do we do next? Well, we have to capture, process, and store and make available that data. So far, we have only set up everything, and now we can read that data out, but we have to read it out and we have to store it somewhere. So the next 6 weeks are spent going through masterclasses and online courses to understand how we can build something on Microsoft Azure. We basically decide to repurpose our Python scripts on the edge. We use Azure IoT Hub to stream that data in. We have lots of certificate handling that we do manually, which is not optimal, but we believe we can automate that at a later point. We then use Azure Stream Analytics to basically just stream that data from Azure IoT Hub into Azure Postgres, and we have set up a time series table to store all that data. And everything is working on the cloud. We turn on the Python scripts on the edge and hope that data is pouring in, and we actually see that data is pouring in, but only for the pilot machines. We're somewhat confused, go to the shop floor, look at the OPC tags and notice something. The OPC tags aren't really the same. They look different on every single machine, but the pilot machines, which brings us to one of the, let's say, more overlooked topics of data connectivity and PLC connectivity in specific, namely that it's about data harmonization. So if you think about this, like every single PLC is programmed by some PLC programmer, and the program code of them defines the naming scheme of the process parameters you're looking for. While we always think about, let's say, pressures, temperatures, speeds, and whatnot, the PLC actually knows tag names, and those tag names correspond to whatever the PLC programmer has deemed to be a worthy naming scheme. So this means that each and every data source has to be searched to map from this data source tag realm into the semantic realm. And this is something that's this is like really tedious and has to happen on every single data source. Also, sometimes you have to scale the variables. Some data sources have really weird units like decimeters per second or something, although you want meters per minute, and that's also something you have to figure out by looking at the data. Sometimes also the equipment manufacturer can help, but more often than not, they really can't. So the ideal world is basically gone. This doesn't work. So what do? We basically come up with a unified naming scheme that helps us to kind of keep these stable identifiers across all the machines, and we implement that throughout all the naming space that we want, like temperatures, pressure, speed, whatever, and then we basically go and duplicate all that Python code that we have written here to map from the data source tag names to our new names that we have come up with. This is already really tedious. We make a lot of errors and we don't know how to scale this, but we say, okay, we'll figure this out eventually. Can't be that hard. In that minute, some of our colleagues come in and say, the workers say that the values from the stacking machine will really help them to fix a problem and to do just like to, yeah, decrease a lot of scrap as well. And we figured out, okay, what would we need to do to actually add some new variables, and we figure out, okay, this is going to be really complicated. Like, we have to find the tags, we have to adapt the strips, we have to adapt the jobs, and we also have to extend the time series schema, which makes it really, really bad and really, really hard to do so, and it's mind-boggling even for the person who has invented this system. But we are saved, because in that minute, the COO calls and tells you that the CEO has scheduled a demo before Cologne and Pulheim, and next week works, right? So you know, okay, you can't really deal with this right now, you have to get going, and you just repurpose the Grafana application that you have built before. This is working already, and you make it basically in time for the big presentation. And this is how the setup looks now, and today's demo day. What do? COO, site, and production managers take part. The problem and the solutions are presented. You emphasize, hey, this is only just one use case. Like, the data foundation is here for each and every one of you. I will talk to you. I will get your departments to share your problems, and we work on solutions. It's going to be great. It's just be the beginning. And in that moment, the notifications are dispatched, the workers run to the machines, they get it back to operation really quickly. Everybody is super thrilled and starts asking questions like, okay, this is great, but I need these 500 other values in for this machine as well. And other people inquire, is it also possible to get product-based alerts? Because it doesn't really work that way, that we have only alerts for like globally. And other people ask, okay, can we also use this data to calculate product-based energy consumption with AI? And you notice, okay, great, I'm tapping into something here, but I'm kind of getting, I'm being the victim of my own success. And obviously, this is just an anecdote, and it's really hyperbolic, but how does this map into the questions that I asked earlier? So first of all, like, what does it need for digital transformation? We believe it's one first use case and a scalable data infrastructure, because if you think about it, all that effort that you put in, getting machine data, also getting other data types in, it's a lot of effort, but the use case is what actually delivers the value. So you always have to figure out, okay, what are the departments doing? Where's the pain point? Where can you deliver value with data? Because otherwise, data is just being dumped somewhere and nobody is working with it just by nature. And thus, it doesn't make sense to build one specific use case with like all that data integrated, and then you start a second use case and have to put in all that effort again. Also, in that anecdote, I hopefully showed you how bad it can be if you just have a prototype and you don't have a system that kind of enables others to also work in it, continuously discover and add new data, because the system we have built up so far is really unscalable and really hard to change. And this is basically also the second answer to the question, namely, what are technical challenges of digital transformation? Doing this for the past 6 years, we believe that the biggest challenge actually is developing, extending, and operating an integrated system that non-IT experts can handle. Because obviously, now we as digital transformation managers have built something up, but even us now struggle to change it, add new data sources, add new variables. It's a super manual process, and once you do an error, everything goes down, and obviously the trust in the data is corrupted, and this can really work. And this also is kind of like the paradox of digital transformation for us, at least. 90% of the effort goes into building the scalable infrastructure, where you can just have a UI, add new data sources, add new variables, start capturing data, and then pipe it into the right systems to enable others to make better decisions or to act faster. But the use cases are just like 10% of that effort. While when you look at the value add of infrastructure most of the time is negligible, close to zero, while the use case is the thing that actually delivers the value. And we didn't even touch on issues such as IT and OT security, authentication, authorization, like how can we actually connect this to our Azure Active Directory so that we have single sign-on? How do we process that data? How do we make the system resilient? And also, how do we keep like our sanity when we have to do on-call rotations to keep that system up and running? And how do we monitor that? And yeah, that's basically all these topics that are extremely based in, let's say, high tech and running servers and whatnot, and are often overlooked when you start with a really small prototype such as a Raspberry Pi running in production, and then have to scale that up to, let's say, 50, 100 machines, or even 10 production sites. And last, why does it start so quickly and then slow down so fast? This taps into what I said just now, namely, like, first of all, prototyping versus productization. In software, it's really easy to come up with a working prototype that does one thing and has a lot of assumption about the real world. But as soon as you want to build a system that allows everyone to configure it, you have to get rid of these assumptions, do all the error handling, and basically build all the edge cases around, which is extremely hard and takes a long time. Second of all, unknown unknowns also play a huge role, because obviously IoT, getting data out of machines, doing data analytics is something that hasn't been around for the past 30 years. So you don't have many people who have gone through projects 10-fold or 20-fold and have the lessons learned and know how to, well, what to do and what not to do. So it's a continuous learning process where you run indoors, and it takes a long time to learn as well. And the third, why you don't simply look up, take a step back and ask yourself, okay, is this actually something I want to do, or should I maybe look for other solutions, is the sunk cost fallacy. Because obviously, if you haven't done this before, you always think, okay, I'm already there. It's just this peak I have to cross, and most of the times it isn't, and then basically you get stuck. Like, we continuously talk with people who have invested in this. They started this 10 years ago, and now they have like 7-digit maintenance costs just like for 20 teams maintaining and operating that infrastructure they have built up, and not even innovating on that. And that's basically, yeah, why people get stuck in this. It's also really hard for everybody, but I hope I have shed some light on why this, answer the questions. And if you have any questions, I think this is a Q&A session, but you can reach out to me. These are my credentials, and happy to talk.
Thank you. Thank you so much. How do you support your customers?
Okay, yeah, great question. As I said, I didn't want to advertise, but basically what we do is we have built a data infrastructure that allows us to basically onboard data sources of brownfield machinery really quickly. So usually we go in, we install our edge devices with our customers, connect the machines, and then after everything is onboarded, it takes about 2 hours, 3 hours, and the data is already flowing. And then we have basically, let's say, like turnkey solutions in the realm of productivity management, where you get automatic downtime detection, you get automatic recipe management based on machine data, so that you can actually get your product variance down. Because many of our customers have the problem that depending on who the worker is that is setting up their machines, they have a huge variance in performance in terms of meters per minute or kilograms per hour, for instance. And by just observing the data and understanding this and benchmarking the same batches, production runs, or products on the same machine, we are able to tell which parameterization actually led to the best production. And then we enable the operations manager to have this digital SOP where they can just say, okay, this is my recipe, and I want to load the recipe from this production run into that recipe and push it down to the workers. And this kind of enables them to continuously improve their production.
So I apologize because I'm a recovering print buyer from an advertising agency.
No worries.
So most of what you said, I was like, what? So based on that, how technical does someone on the print shop side need to be to work with you? And if they aren't, can you still support them, and how?
Great question. So actually, our product has been built with the customer in mind. So while we do a lot of stuff that is rather technical to get the data in, we go to lengths to build a product that is actually usable by operations managers and production managers that haven't gone through data science training. So it's really, I would say, really easy to get started. I encourage you to just check out ENLYZE.com. We have a product video and a demo for you on there, so you can just browse and have a look. But it's like the first step is just starting to be accustomed with integrating data into your everyday life, understanding, okay, let's say last week, what did I do? Like, what were the products I produced, or the production orders that I produced? Did I have a lot of downtime? And then maybe go into why do you had it, to then understand, okay, do I have levers for optimization here? Is it performance? Is it quality? Or maybe is it even downtimes that I can optimize? And we also enable the shop floor workers to label downtimes that we detect automatically, just based on the machine data after the fact, so that they can focus on bringing the machine up and running again, and then they label it afterwards. This finds huge adoption, so it's way, way easier to get real-life bookings that make sense, which are the actual manufacturer reality, how we call it. And then you can exchange in a conversation about, okay, why is this happening? And it's not anymore like a gut feeling-based thing where you have two sides, but you can look at the same data, understand why it's happening, and rather derive actions, how to alleviate, let's say, downtimes, instead of just being rude to your workers and hoping for the best that this actually does the job for you.
Wonderful. Does anyone have any questions? Anybody? Anybody? Okay. Thank you so much. Really appreciate it, Dennis.
Thank you.
And ENLYZE is here, and go check them out. Check them out online. And thank you, everybody, for attending this session. Appreciate it.